Here we're going to have a look at ores, what makes an ore and how we extract the metals from that ore. And you might be quite familiar with this term, not just from school, but from things like Minecraft and stuff like that. So let's have a look at what defines an ore. So an ore is a metal, is a substance where a metal can be extracted for profit. So to think about what that means, you have got metal in your body. You've got iron, you've got sodium, you've got potassium, you've got all sorts of different metals, and they're vital to make you live. I could theoretically extract all those metals from you, but in order to do that, it would cost me a huge amount. Number one, in sort of the actual process of doing it, probably in legal fees as well, because it would not be a legal thing to do. Now, in the process there, I would still extract some metal. The amount of metal that I would extract would not be enough to cover the cost that it took me to actually get it. So you would not be considered an ore. So most ores are minerals. In fact, all ores are classed as minerals. They tend to be rocks, and not all rocks are ores. So it's only the ones that have very high concentrations of metal. For example, what's now called Uluru, or used to be referred to as Ayers Rock in Australia, would be a very, very big iron ore. It's iron-based rock, and they all look like this sort of stuff. So they just look like ordinary rocks. Tend to be, some of them look a bit more shiny, like they should have metals in. Some of them don't, and often the color is resembles what metals in there. So this one would be hematite, which is an iron ore. Now, we always refer to, or usually, not always, we normally refer to an ore with the ending of "ite." So things like bauxite, hematite, for example, they all end in the suffix "ite," which represents it as an ore. And how are we going to extract those? So we tend to use the reactivity series. Now, anything below hydrogen, so that's copper, silver, gold, platinum, and other metals, they're very easy to extract. You can generally find these naturally just in the bed of a river, because the water is enough to wash off the impurities. Now, anything between carbon and hydrogen, so zinc, iron, tin, and lead are the common examples. They are extracted by reduction with carbon. So we would say reduction with carbon. And we prefer to do that method, and there's a very good reason why we prefer to do that method, because the alternative is what's above carbon, and that is electrolysis. And electrolysis is quite an expensive process compared to getting some carbon and heating up the ore with that carbon. And if we have a think about it, as you go up the reactivity series, it becomes more difficult to extract that metal, which means that as you go up the reactivity series, those metals tend to have only been extracted more recently. So we look at things like copper, and the Bronze Age came before the Iron Age, which came before the Space Age. So between the Copper Age and the Iron Age, we had to discover a way of getting enough heat energy to actually extract and to reduce, because all of this is a reduction. You're reducing the metal and oxidizing something else. So you're always reducing the metal to make it pure and to extract the metal. Now, the Iron Age, you would have needed a much higher temperature to be reached in order to extract it than, let's say, copper. Aluminium, you can't do, because what happens is if you try and heat aluminium with carbon, the oxygen that's on the aluminium has nowhere to go up the reactivity series. All of these, so let's say I've got iron oxide, FeO3, well, actually that iron would go to the carbon because the carbon's more reactive. But the aluminium, the oxygen can't go up to the carbon, so it's not actually going to be reduced. So you need electrolysis to extract it. The problem is electrolysis is a very expensive process to do, especially on mass, compared to this. So as a result, we will always choose this over electrolysis.